Hello guys, so welcome back to Daily Code Work. Today we're going to take a look at records in Java. What is a record class and what does it do? Why do we have records? So I see that the sole purpose, the main purpose of the record class is to carry data, right? From place to place. But this data has to be immutable, which means they cannot be changed, right? They cannot be modified once they are created. So this is the sole purpose of a record. Now let's take an example. For example, we have an application and a user requested for some data from the server. And for us to get this data from the server for the user, we have to create a class and create the object of the class that will hold the data from the server and back to the client. So the main purpose of that class we created is just to carry data for the user. And now creating that simple class actually has to do with creating a lot of boilerplate codes such as getter, setter, generating constructors, generating hash code method, equals method, and toString method, and so many boilerplate code like that. But with record, the purpose of record is to get rid of those boilerplate codes. So we don't need to generate all these getter, setter, and all those toString, so on and so forth, explicitly. So the moment we create a class using the record keyword, all these boilerplate codes are generated for us. Now, before we talk more about record, let's quickly go to IntelliJ and take some example on how and see how records actually work. So for that, I'm just going to create a project, a new project called record demo, right? So I just call this record demo and just leave everything here on default. So I click on create. So right here we can see that our project has been created here, and this is our main class, right? So this is our main class. And quickly, I'm just going to create a class called student here. Let's create a class. So we're going to demonstrate this using the traditional Peugeot we are used to for many years, right? So yeah, just do this, just add it, right? So here we have a class student, and the student is going to have a few attributes, right? So now I'm just going to have the ID of the student and the name of the student, name and email. Here. So now if we go here, so now before we can use this class, there are some other things, there are some other boilerplate code we have to generate, right? So let me go here. Let's quickly go to our main class and try to use the object we've just created, the class we just created. So for that, we're just going to create the object of the student equals new student, right? Equals new student. So now I'm going to pass indirectly the values. So here I just have the ID as 1 and the name as Sam and the email as email, right? Email here. So now have this, and now we see that before we can use this, we have to create a constructor, right? As usual. So we have to create a constructor here so that we can actually access, to override, to get rid of this error. We need to generate a constructor, a parameterized constructor here, right? So now I'm just going to use IntelliJ and Windows. I'm going to press the alternate key and insert to have this pop up for us to create the constructor. So I'm just going to choose all three attributes. So now we've gotten rid of this, right? Sorry, we have a problem here. This is new. Yeah. So now you see that we have gotten rid of this. Okay, this one is what is it? Okay, it's supposed to be long value. So let's just put L here. So now we have gotten rid of this by generating this constructor here, all arg constructor, right? A constructor that contains all the arguments we have, all the parameters we have for, all the attributes we have for the students, right? So now I'm going to run this and let's see what we got. Okay, so we have seen that, sorry, I have to print it out. I didn't print out S, right? So here I print S. This one's supposed to be, yeah, print at S. So now I run it again. Okay, so coming here, we can see that we actually got the object of this class, right? We got the hash code, that is the object of this class. This object representing this new student object we've created here, right? Which is this one here, this new student object we've created here. So now, how do we get out the plain value? How do we see the plain value? What we're going to do here is to come back and we have to generate the toString method, right? So for this, I'm going to press the alternate key and the insert key, and scroll down here to string method and just add all the field we want to display. We want to show the values, and we click on OK. So now we have gotten the toString method. So if we go back here and run this application, let's run it and see what we got. All right. So now, having added this toString method, we see that we are able to get out the plain value of the student object we've created, right? And the purpose of this class is just to hold data, right? It's just to hold this student info from the database down for the user. And for us to do that, we have to generate all these. If we want to go further to start comparing, doing this, doing that, then we have to implement the equals method, and we have to override the equals method and the hash code method if we want to compare two objects, right? And if we want to do some modification, like for example, I want to change the name of this student. So now I can just say, okay, x.setName. I want to change the name here. x.setName. I want to change the name from Sam to John, right? And after this, I just want to print out the student again one more time. So I print it here again. Now we can see that setting the name here, we need to generate this getter setter right here to get rid of this error, right? So for that, I'm going to come back here. And press the alternate key and the insert again. And here I'm going to generate getter and setter. Yes, I just need all, and I click on it. So coming back here, we have done this successfully. So now if I run this application again, we see that the name of this user, this student, has been changed from Sam to John. So let's run it and see what we got. Okay, so we can see that the first one here printed Sam, and after changing the name has become John, right? We've changed the name from Sam to John, right? Now, this is just the simple task we wanted to achieve. But doing this here, look at all the code we generated, right? These are all the codes. Look at the class, it's like how many lines of code. So here we get like 44 lines of code, right? Just doing that. Now let's do the same thing with record. So right here, I'm going to create a class called student record, right? So we're going to name this class as student record. Student record. So this time around, instead of choosing the class, I'm going to choose the record keyword and click on enter. So we have created a new record, an empty record, and we can see that we have a close and open and close parameter parentheses here, just like a method, right? So in here we have to pass in the attributes we want we want to get for the user, right? So this one here, we don't need to pass any access modifier. We don't need to put private or public. We just put directly the type of the attribute and the attribute itself. So the type of this attribute is going to be long ID, and the name is string, right? String name. And the email also is of type string, email here. So now we have done this. Notice that we have not generated any boilerplate code here. We just declared this only, right? So now let's go back here and let's go back to our main method, and I'm going to comment this out. I'm going to comment this from here. Just comment it out. So we're going to make use of the new student record we've just created, right? Make it fast. Student record equals new student record here. So now I'm going to just pass in the same value like the other time, right? So I'm going to pass in 2 here, and the name is going to be Sam as well, and the email also is going to be email, right? Now notice that we have not gotten any error. This one is a long value, so let's put L. Now you notice that we are not getting any error here, right? So let me uncomment this. So I'm going to put something here using records. So here is record. So I'm going to uncomment this so that we demonstrate something here, right? Okay, now let's take, for example, I want to come back here to the students and comment out the constructor. So now I want to comment out the constructor. So if we go back here, we got an error, right? Because we must put a constructor here for us to be able to access the students. But in the record, in the case of the record, there is no constructor here. All we just did was creating the record class and the attribute of the student we want, right? But we are able to use it here without any complaint, right? Okay, cool. So now I just want to let me comment it out again. Let me uncomment this rather. Let me remove the comment from the constructor to get rid of that error. Okay, so now let's run this application and see what we got. Okay, I just run the application here and see what we got. Oh, sorry, I didn't print this out. I'm so sorry for that. So let me sys out this. Sys out SR, right? So let's print out SR, and I'm just going to run this again. Okay. So now we see that here we have student record, right? And we are able to get the data from the record. And this one is the student, right? So we are able to get the data from the record. Notice here that we didn't create any constructor, no getter, no nothing. And that is because when we created this record, the JVM automatically generates an all arg constructor. So the same constructor here, just like this constructor here, was generated for us here under the hood. So we don't need to explicitly generate all these things, right? So all these getter setters, everything we created here by hand, everything we generated here by hand are generated for us here automatically under the hood when creating this. So that is the purpose of a record. Now, if we want to remove all this, here from here, for example, we don't want to generate all these getter setters to string and all these things. Before, we have to add a lombok annotation, right? So we have to have some lombok. We have to make use of the lombok. So maybe we put at getters, at setters. That is the annotating. We have to annotate the class here. In that case, we have to annotate the class, right? Maybe by using at getter, at setter, at all arg constructor, all those things for us to get it. But with record, we don't need to use any annotation by default. The moment we create a record by default, all these things we get for free. And there are some other things we can actually do here. For example, I want to validate, we can generate our constructor here. We can actually generate a constructor here for validation, right? So for example, I want to validate the name of the student to make sure the name is not null. So for that, I can just have to generate my constructor here, like public student record, right? This student record here, which is the compact constructor. Sorry, what happened? What's happening here? Yeah, so here I can generate my compact constructor here. Yeah, so now inside this constructor I can validate what I want to validate here. So for example, I can just say, okay, if name equals none, or name dot is empty, or dot is blank. Let's use blank. Here I can say, okay, throw an error, new illegal argument exception. So here I can just say, okay, name cannot be empty. Name cannot be empty, right? Here. So we can actually do some validations. You can validate anything you want to validate here by just generating a compact constructor here, right? Because a canonical constructor has been generated for us under the hood. That is the constructor, that's the all arg constructor. A constructor that contains all these arguments has been generated for us, and that constructor is called a canonical, right, constructor. So that constructor has been generated for us under the hood. So here we can generate our own compact constructor for validation, or to do whatever I want to do here, and it will still work. So now if I go back here, and for example, let me remove this. Let's allow the name to go blank and see if we get any message or not. So let's run this and see what we got here. So now we can see that name cannot be empty. That is the message we define here, right? So this is the message we define here. Name cannot be empty, right? Because the name is blank. Now let's try to come here again and put it as none. For example, let's make it none here and run it again and see what happens. You see? So here we still have the same error, name cannot be none. So I'm just going to put it back as normal name, like Sam, right? So let's run it again and see. So now we are able to print out the value. So now you can see that using the record, we have a clean class, a clean data carrier class, that data transfer class object. It's called data transfer object, right? Just like what we were using before. So we have gotten a clean class that can carry data from place to place in our application without generating too much of boilerplate code to do that, just like we did here in the student class. But remember that these two classes are doing the same thing. They are created for the same purpose. But look at the amount of code we generated here, and the record, look at what we got here. Now, one thing we should know that this record here, this record class here, any class that you created with a record you cannot extend another class. You understand? So for example, if we try to extend here, like extend, for example, maybe extend, what do we want to extend right now? Okay, let's extend something here. So let me just zoom out a little bit. So you see that here it said remove extend list, right? No extend clause allowed for record. You can see here. So a record cannot extend another class, but they can implement any other interface. They can implement interfaces. Now, the reason why record cannot extend another class is because under the hood, this class, any class that is created with a record, is directly automatically extend the record class, right? So that class automatically extend the record class. So in Java, a class cannot extend multiple classes. So that is the reason why any class, a record, cannot extend any other class. We can only implement another class, right? So now we can see the purpose of a record right here. So like I said earlier, the sole purpose of a record is to carry data for us, immutable data. Now, for example, here I can change this here. I can change this. I change this here, but I cannot change this here. This one cannot be changed. Now, for example, if I go here and say, okay, let me change this. Okay, let's take, for example, I want to modify this name. I want to change the name of the student from Sam to John, just like we did here with the other classes, right? So right now, if I come here to say sr.setName, sr.setName from Sam to John, right? JOHN to John here. So now it's going to tell me, it's going to ask me to create this method here. So create this method here, right? So I'm just going to change this to name, and let's see, this dot name equals name. So right now we're trying to modify this name here, right? So we try to assign, like changing the name of the student of the record. But now let's look at this error here. Cannot assign a value to a final variable. You see here, because now this variable here, all these variables automatically they are final. The record class is a final by default, and all the fields in a record are all final, so they cannot be changed. So the moment a record object is created, it cannot be changed. The values cannot be changed, so it's final, right? So that is why I said that the sole purpose of a record is to carry data that are immutable in our application. So that is the purpose of a record. So now let me just remove this, and before we round up this video, let's quickly take a look at some key fact about a record. So here we have some things here. Record cannot be subclassed, right? Meaning they are final by default. Now the traditional class, the traditional Peugeot class, if we want to make it final, we have to use the final keyword here. But a record, the moment we declare a record class using the record keyword, automatically that class is a final class and cannot be subclassed. Now, two, we have record cannot extend other classes, just like as we have seen in the demo, in the little demo we have shown. Record cannot extend another class because once we create a class with the keyword record, that class automatically extends the record class in Java, right? So because in Java a class cannot extend multiple classes, so that is why a class created with record keyword cannot extend another class. So here, if we look here, we can extend this, but here we cannot extend. Using record, we cannot extend it. It's not allowed. So let's go to 3. So here we have records are immutable. Once they are created, their values cannot be changed. Just like as we have seen, while we try to set the value, we try to set the name from Sam to Jean. We are not allowed to change the name because they are final by default. So once a record is created, it cannot be modified. The values cannot be modified, right? So here we can use the set name here to change the name of this traditional Peugeot class we have. But coming to record, we cannot use the set name here to change the name. So it cannot be, it's not allowed. It's a final. It's final, right? So here we have, again, record generates all arg constructor by default under the hood, just like the traditional Peugeot class generates a non-arg constructor. Now, if you remember, when we create a Peugeot class, the traditional Peugeot class, that class automatically, the JVM automatically generates a non-arg constructor for us, an empty constructor for us, right? But in record, the JVM will automatically generate an all arg constructor, a constructor that contains all the argument, all the attributes we have in the record will be automatically generated for us under the hood. So we don't need to generate them more, generated explicitly, right? And the last one here we have the record will actually generate all the necessary method we need for our class to run properly, right? All the default things like getter, hash code, equal to string, all arg constructor, except the setter. It will not generate setter because setter will allow us to modify the attribute. Because they are finer in nature, the class is a finer in nature and all the attributes are finer in nature, so we cannot, there's no setter method, but every other method is generated for us automatically under the hood when we create the class, right? So here for now records cannot be used as entity class, maybe like persisting to our database as entity, maybe using the JPA entity. Record cannot be used. Why? Because JPA implementations like Hibernate depends on entities that have non-arg constructors, non-finer fields and setters. It needs setters and non-finer classes. That class must not be finer, right? Because it will be subclassed by others and it will be modified. The data, the information there will be modified from time to time. Because record is a finer class and all the attributes are finer, so it cannot be used as an entity class for now. So this brings us to the end of our little talk on record. If you have any other contribution, please don't forget to drop a comment on the comment section. Let's discuss together, right? And please, if you have not subscribed to my channel, please don't forget to subscribe and don't forget to like and don't forget to share. Thank you for coming around and hope to see you in our subsequent video. Thank you and have a nice day. Goodbye.